Here we go. We have a question. Find the first node of loop in linked list. So you have given a head of a single linked list. If a loop is present, then return the first node, else return null. So you have given this, and there's a loop. The pointer, the node is a 3, where the linked list is connected. So the answer is 3 in this case. So in this case, we don't have any loop, so the answer is null. As you can see, we need to return a node here. If it is connected, we need to return that particular node. If it is not connected, we need to return null. So question is pretty straightforward. Let's try to build the approach. We're gonna use the same slow and fast pointer approach. So fast pointer points here, and slow pointer points to the head node also. So fast pointer will jump 2 steps, slow pointer will jump 1 step. Is it equal? Means, is it pointing to the same node? No. Fast will jump 2 steps, slow will jump 1 step. Is it equal? No. I'm not talking about value. I'm talking about node. So now let's continue. Fast will jump 2 steps, slow will jump 1 step only. Fast will jump 2 step, 1, then 2. Slow will jump 1 step. Yes, it is connected. So it will point to that particular node. But this is not the it is not the um, it is not the node that is making a loop. So we need to find 4. How we will detect 4? So it is pointing here. We both the nodes pointing to the same node. So what we can do? We will reinitialize slow to the head node, and then we will try to find the intersecting node. So at this step, slow will jump 1 step, fast will also jump 1 step. Slow, so fast will jump here, slow will jump here. Is it equal? No. Fast will jump here, slow will jump here. Is it equal? No. Fast will jump here and slow will jump here. Is it equal? Yes. So both the nodes pointing to the same node. This is our answer. How we are making sure that if the value is equal, if the node is equal, this is our intersecting node. How we are making sure? What's the verification? So let me show you. So let's suppose you have a linked list like this. A linked list like this. So this is making a loop. This is our answer. Here, this is our answer. So let's suppose this is your A, and after jumping 1 step, or we are jumping 2 steps, so it will surely point to same node. At the end of the day, it will surely point to the same node. Slow and fast will meet surely. So let's suppose they will meet at this particular location. They will meet at this particular location. So the distance between this and this, let's say this is B, and let's say this is C. Okay. So fast will jump 2 step, slow will jump 1 step. Distance. So let's make a formula. Let's derive the formula. Distance traveled by slow pointer multiplied 2 is equal to distance traveled by fast pointer. Yes, we are making sure that slow will jump 1 step, fast will jump 2 steps. So that's why if we multiply slow by 2, it will surely travel the same distance. So let's suppose fast start from here, then do some looping, and at the end reaches here. At the end reaches here. So what's the formula for what's the total distance traveled by fast pointer? A plus some number of times B plus C. Let's say m number of times B plus C plus B. This is the distance traveled by fast pointer. And what's the distance traveled by slow pointer? So slow will start from here, do some looping. Sure, sure that it will do some less looping, but at the end it will also meet at this point. So we can say A plus B plus C, it will do some looping n number of times, then again it will reach to B. Then we have to multiply by 2 because this is the distance traveled by slow pointer, and multiply 2. Now let's derive the formula. A plus B plus C n plus B is equal to B plus C divide M. So we have A plus B is equal to M minus N B plus C. So this is the distance, means the number of looping. Obviously M is greater than N because M is the number of loops traveled by fast pointer. So we have this formula, and mm, let's give it an special symbol. So let's say this is the lambda. A plus B is equal to lambda of B plus C, lambda of B plus C. So let's suppose lambda is 1. Lambda is 1. So we got A plus B is equal to B plus C. So we got A is equal to C. Let's suppose lambda is 2. So again A plus B is equal to 2B plus C, 2B plus 2C. So we got A is equal to B plus 2C, B plus 2C. So B plus C is a loop. B plus C is a loop, yes. So B plus C is a loop. So we also got A and C. So that's why A and C is equal. So this distance and this distance is equal. So that's what happened here. Slow and fast will meet at this particular point or any point in the loop, yes. So starting from this node and starting from the head node, we will travel the same distance. So fast will point at 5 and slow will point at 1. So it will have the same distance. So is slow and fast equal? No. So slow will jump, fast will jump. Is it equal? No. Jump one more step. Is it equal? No. Jump one more step. Is it equal? Yes. So 4 is our answer. Let's code this. We have slow and fast. While this condition holds, slow will jump fast will jump 2 steps, slow will jump 1 step. If this condition is true, just break out. If this is true, it means we don't have any loop. This is a singly linked list. Return null. Else, what we'll do? Slow will point to the head node. So we have slow and fast pointer. It will make 1 and 1 steps. So slow and fast. While this condition is not true, we are inside the while loop. Slow will jump 1 step, fast will jump 1 step. At the end of the day, slow and fast will travel the same distance and will reach at the intersecting point. So that's how it will work. I also derived the formula. Let's submit this. Let's talk about time and space complexity. So we are doing some number of loopings and we are inside the while loop. So overall it will be order of n, but it will be constant like 2n, 3n, 4n. So number of looping, but overall it will be order of n, and we don't utilizing any space. So the time and space complexity, we have met the expected one. And if you like this video, give it a thumbs up, subscribe to this channel. Thank you all for watching this video.